Well, hello everybody, I'm back and I wanted to solve two of the harder problems from the final exam study guide. Both problems use this rational equation. The first problem asks you to find the LCD, the least common denominator. That is, what would you multiply both sides by so that the fractions here would collapse, they would vanish, and you'd be left with a much simpler problem to solve. So it was simply to identify the LCD. The second problem asks you to actually solve this thing for x. And I'm going to show you a bit of a trick for doing both of these things at the same time. It's a bit of a hack in that it eliminates two complicated steps where I've noticed a lot of people fall down. Um, so it removes complexity the way I'm going to do this. My first move is to create space to work. This is a rewrite of this. And I've created space to work by extending these fraction bars. The first rule of good craftsmanship is to give yourself space to work. You don't want to have scrunched up things because you're going to go awry if you do. So give yourself space to work. I know I'm going to put factors here, so I create these elongated fraction bars. Then I parenthesize all the denominators. And so the x plus 2 gets parenthesized here. And then I factor all trinomials and binomials. Notice this binomial factors. It has a common factor of x. And so I factor it and then I make sure everything is parenthesized. So always, these are my first three moves. And once that's done, we can get after actually solving this thing. And as my technique, as I solve this thing, I'm going to build up my LCD over here. I'm going to do both at the same time. Now, one other thing we need to be very aware of, and that is what x can't be. I'm going to go ahead and show you that x can't be negative 2 or 0. And that's because if x is 0, we'd have 3 over 0, which is a no-no. You can't divide by 0. And same here. If x was a negative 2, this quantity would evaluate to 0, and we would be dividing by 0. And the same holds for here. So I note up here what x can't be. And then I go ahead and work my solution here. And now we're ready for the bit of a hack. And it's just based on some intuitive thinking. It's not difficult at all. I asked myself, wouldn't it be nice if I had an x here? Because then I could cancel and this fraction would be gone. So it would be very nice if there was an x here. And so let me go ahead and do this. Let me put an x in right there. In other words, what I've done is I multiplied this first fraction by x. Of course, we have an equation, so what we do to one side, we have to do to the other side. So I need to multiply this side by x too. But of course, I didn't multiply this whole side by x. Both terms have to show this multiplication by x. Both terms. And so I need to multiply this term here by x. So everything gets multiplied by x. And now I play the canceling game right now. And I say, look, this is going to cancel. And isn't that nice? The fraction is gone from that first term. Nothing cancels here. But notice the x's cancel here. And we are moving along this problem. We are building up the LCD as we go. We've multiplied both sides by x so far. And now again, I ask myself, wouldn't it be nice if, well, I had an x plus 2 right here. If I had an x plus 2 right there, it would cancel this x plus 2 in the denominator and the fraction would be gone. Of course, that means everything has to get multiplied by x plus 2. And so I show it. And now we're once again into the canceling game. Nothing cancels here, it's not even a fraction anymore. This cancels and the fraction has vanished. And this cancels and the fraction has vanished. And I go ahead and note that I multiplied both sides by this, and I have solved, since there are no more fractions here, I have solved figured out what my LCD was. It was in fact x times the quantity x plus 2. And now we are almost home in this problem. It's going to devolve very fast here. We are simply going to clean it up, and we're going to have 3 times x plus 2 plus x squared equal to 4, which looks like this. And I'm thinking here in terms of a quadratic equation, so I'm going to write this in descending orders of power. I'm going to do this distribution. I'm going to get 3x plus 6, and we'll have this right here. And now you know the technique for solving a quadratic. We get everything on this side and 0 on this side. I'm going to subtract 4 from both sides. And when I do that, I get this. And now the question is, can we solve it by factoring, or do we have to use the quadratic formula? And this trinomial actually cracks, and when you factor it, it looks like this. And now we are, basically in an earlier chapter. Two numbers multiplied together gives 0. Whether this has to be 0 or this has to be 0, that means either x is negative 2 or x is negative 1. And so I'm thinking, here are my solutions. But, yes, I said that x can't be negative 2. So we have to eliminate this. And this supposed solution, it's not a solution. And we're left with x is equal to negative 1. And so there you go. That's how you solve these things. One technique. Build in the LCD as you go and cancel mid-problem and keep track of your LCD as you, like I did when I put the x's in. I made sure I built my LCD up here. I multiplied everything by x plus 2, built my LCD. And of course this trick at the very start, what x can't be. So there you go. I hope that helps. It's two of the harder problems on the exam. Maybe I can work another one to familiarize you with this technique. Thanks for listening.